Close your eyes for a moment. Picture the universe. A vast, silent black canvas. It is sprinkled with the light of 1,000,000,000,000 galaxies like luminous dust scattered by a careless hand. For so long, we believed this scattering followed a rule, a fundamental principle of cosmic fairness, a law that put a limit on how large any single pattern could be. We thought we understood the architecture of the cosmos, but we were wrong, because out there, in the deep and ancient dark, something is hiding in plain sight. Something that breaks the rules, a structure so impossibly large, so profoundly gargantuan, it tears a hole in our most cherished theories. It is called the Giant Arc, and in this journey we will drift through the void to witness this impossible object. We will explore how it shatters our understanding of everything, and we will be left to wonder, and what else is hiding out there, waiting to rewrite the story of the stars. To truly grasp the shockwave this discovery sent through the scientific world, we must first understand the bedrock it cracked. For nearly a century, our map of the universe was built upon a single, elegant, and powerful idea. It is called the cosmological principle. This principle is not a complex equation, but a profound statement of humility. It declares that on the largest of scales, the universe is homogeneous and isotropic. In simpler terms, it means the universe is basically the same everywhere and in every direction. Imagine you are in a forest. Standing on the ground, you see individual trees, unique clearings, and distinct rock formations. It looks complex and varied, but if you were to ascend in a balloon high above the canopy, the forest would smooth out into a single, even, green carpet. That is the cosmological principle in action. It suggests that while we have local clusters and superclusters of galaxies, once you zoom out far enough, it all averages out. There are no special places, no center, no edge. This wasn't just a philosophical preference, it was a practical necessity. It allowed us to create the standard model of cosmology, to trace the echoes of the Big Bang, and to make sense of our place in the grand cosmic scheme. It was our comforting guide in the infinite dark, a rule that brought order to the chaos, a cosmic speed limit on structure size set at about 1.2 billion light-years. Anything larger was considered a statistical impossibility. This principle was the foundation, and the giant arc is the earthquake shaking it to its core. So, how was this cosmic titan found? It was not seen through the lens of a telescope like a distant, shining nebula. Its discovery was a masterpiece of cosmic detective work, a story written in the ancient light of the universe's most powerful beacons. The year is 2021. A PhD student at the University of Central Lancashire, Alexia Lopez, is meticulously poring over data from the Sloan Digital Sky Survey. This is one of the most ambitious astronomical surveys ever undertaken, a project that has mapped a massive swath of the night sky in stunning detail. But Lopez wasn't looking for galaxies themselves, she was looking at what lies between them. Her method was ingenious. She used quasars as her tool. Quasars are the intensely luminous cores of distant young galaxies, powered by supermassive black holes. They are so bright, they outshine everything around them, acting like cosmic lighthouses, their beams piercing billions of light-years of empty space to reach us. As this ancient light travels across the cosmos, it passes through vast, invisible clouds of gas and dust that hang between the galaxies. When the light passes through a cloud containing magnesium, specific wavelengths of that light are absorbed. Here on Earth, astronomers can analyze the light from a quasar and see these missing pieces, these dark lines in its spectrum. They are called absorption lines, and they are like cosmic fingerprints, telling us that the light has passed through a specific type of material. Lopez used the light from 40,000 of these quasars scattered across a huge patch of the sky to map the locations of these intervening magnesium clouds. She was essentially using thousands of distant flashlights to reveal a structure that was otherwise completely invisible. What she found was not a random distribution, it was a pattern. A breathtaking, elegant, and utterly impossible curve of matter stretching across the sky. This is how the giant arc first revealed itself, not as a flash of light, but as a subtle shadow cast across the face of the cosmos for billions of years. Let us now try to comprehend the scale of what Alexia Lopez uncovered. The numbers are so vast, they almost defy human imagination. The giant arc is located approximately 9.2 billion light-years from Earth. This means the light we are seeing from its constituent parts began its journey when the universe was less than a third of its current age. We are not seeing the arc as it is today. We are looking at a cosmic fossil, an echo from the universe's youth. But its distance is not its most shocking quality. It is the sheer, mind-breaking size. The structure forms a nearly symmetrical crescent of galaxies and matter, stretching 3.3 billion light-years from end to end. Let's try to put that number into perspective. Our own galaxy, the Milky Way, is a respectable 100,000 light-years across. If the Milky Way were the size of a single grain of sand, the giant arc would be a string of sand stretching for over 31 miles or 50 kilometers. It occupies about 1/15 of the radius of the entire observable universe. Think of all the constellations you can see in the night sky from Earth. This single, coherent structure stretches across the sky for a length equivalent to 20 full moons placed side by side. It is a filament of the cosmic web, so pronounced, so enormous, that it dwarfs nearly every other known structure. The Sloan Great Wall, once a champion of cosmic megastructures, is less than half its size. This is not just a line of galaxies that happen to be near each other. It is a connected, gravitationally related entity that moves together through the cosmos. It is a single, cohesive piece of the universe that is, by our best understanding, far too big to exist. The cosmological principle, our bedrock, had set a theoretical size limit for cosmic structures at 1.2 billion light-years. The giant arc casually breaks this speed limit, exceeding it by a factor of nearly 3. It is a profound anomaly, a piece of the puzzle that doesn't just fit poorly, it seems to come from an entirely different puzzle box. So, we have a structure that is nearly 3 times larger than the maximum size allowed by the standard model of cosmology. What does this truly mean? It means the problem is not just statistical, it is fundamental. The first question scientists asked was, could this just be a random fluke? A chance alignment of galaxies that merely looks like a coherent structure from our vantage point on Earth? Alexia Lopez and her team calculated the probability of such a massive structure forming by pure chance within the framework of the standard cosmological model. The number they arrived at is staggering. The likelihood of the giant arc being a random statistical fluctuation is less than 0.00003%. In scientific terms, this is often described by a sigma level, a measure of statistical significance. A 5 sigma result, which has a 1 in 3.5 million chance of being random, is considered the gold standard for a discovery. The giant arc registers at 4.5 sigma. It is so statistically unlikely to be a coincidence that we are forced to conclude it is a real physical object. This leads to the next, more troubling question. How could it have formed? The universe is 13.8 billion years old. According to our understanding of gravity, there simply has not been enough time since the Big Bang for gravity to pull together a structure of this magnitude. Gravity acts locally, pulling matter towards other matter. To build something 3.3 billion light-years long would require a level of coordination and a timescale that our current physics cannot explain. It's like finding a perfectly constructed skyscraper in the middle of a desert with no evidence of workers or machinery and concluding it must have been assembled in a single afternoon. The existence of the giant arc suggests one of two possibilities, both of which are revolutionary. Either the early universe was not as smooth and uniform as the cosmological principle assumes and contained massive primordial structures that we don't know about, or the forces that shape the cosmos, like gravity and dark energy, behave differently on these immense scales than we currently believe. Both possibilities tear a page out of our cosmic textbook. So we find ourselves standing at a precipice, gazing out at the faint, ghostly light of the giant arc. It is so much more than a distant collection of galaxies. It is a question etched across the cosmos in a script 3.3 billion light-years long. It is a whisper from the infant universe, telling us that the cosmos is grander, more complex, and profoundly more mysterious than we ever dared to imagine. The comfortable, orderly map we once held, the one governed by the elegant cosmological principle, may need to be redrawn entirely, but this is not a failure of science. This is its greatest and most beautiful triumph. To find something that breaks all the rules is to be given a new door to open, a new, unknown path to walk into the darkness. Science is not a destination. It is a journey of endless discovery. The giant arc is not an endpoint, but a magnificent new beginning. Thank you for joining us on this voyage to the very edge of our knowledge. The universe is speaking, and we are only just beginning to learn its language. What do you believe the giant arc truly is? A random fluke against all odds, a fossil from the Big Bang, or a sign that we need a completely new physics? Share your thoughts and theories in the comments below. And if you wish to continue exploring the great mysteries with us, please subscribe and join our cosmic voyage.